Okay, so we're going to continue on with section 7.3. There are a handful of problems that we haven't quite seen yet. Some things that will probably trip you up a little bit, things that I want to take a look at before going too far into this. So first thing I want to do, let's take a look at the integral of cosine to the third x times sine to the fourth x. And again, we have to take a look at our tables back in the back, see which ones fit with this. And if you take a look, let's see. This looks like it needs to have table 4, number 23. And that one's a little bit confusing. So if you turn your book back to it, I'll bring it up here to show you. This one right here. A little fuzzy. Anyways, you have your book. It says sine to the m times cosine to the n. If m is odd, let w equal cosine of x. So it says this. We'll write it cosine to the n of x times sine to the m of x. And it says, at least one of them says, if n is odd, let w equal sine of x. It also says if both m and n are even and positive. Okay, that's not true. Okay, so I think that we should be fine there. So let's give that a try. Let's, since n is odd, our exponent of cosine is odd, let w equal sine of x. And there are a lot of different other iterations of this. It just sort of depends on your situation here. So let's try that. Let's let w equal sine of x. That way we can now have no, I think I may want, no, okay, that's fine. We can take the derivative of that, let dw equal cosine of x dx. That way we can solve for dx, dividing both sides by cosine. We're doing u substitution here, or I guess w substitution. And now we'll take this and plug it into the original, along with taking w and plugging that into the original. That should now give us the integral of cosine to the third x. And instead of sine of x to the fourth, we'll use w to the fourth times w to the fourth. And instead of dx, we should be able to plug in dw divided by cosine of x. Now this doesn't look very pretty at the moment. Again, dw over cosine of x can substitute it for dx. That's where the dw over cosine of x came from. And part of the issue that we run into is we still have some x's in there, but luckily we can take the single cosine of x and cancel out with one of those cosines of x's. So that'll leave us with the integral of cosine squared x times w to the fourth dw. Now we still have this issue of having x's in there, but what should become recognizable to us eventually is that we know what cosine of x is equal to in terms of sines, because we know that we have the Pythagorean identity that says sine squared plus cosine squared is equal to 1. Therefore, cosine squared is equal to 1 minus sine squared. So I can take this piece plugging into that cosine square. Now what you might be thinking is, well, that still doesn't necessarily get rid of the x's, and you're correct, it doesn't. Not right away, at least. But I do know that in the original part, we allowed w to equal sine of x. So if w equals sine of x, we can certainly plug in w for sine of x here, leaving us with the integral of 1 minus w squared times w to the fourth dw. And now we have everything in terms of w. We talked a lot about last year in trig and pre-calc that memorizing the trig identities, not terribly important, except for this one. It's the most important one. You'll notice that we've used it on almost every single trig problem that we've done so far. It's very important. Keep that in mind. Distribute through. This becomes the integral of w to the fourth minus w to the sixth dw. Find the integral from that, which means that you can separate those into the integral of w to the fourth minus the integral of w to the sixth, each with dw on it. That would leave you with w to the fifth over 5 minus w to the seventh over 7 plus c, and then plug w back in, which just so happens to be sine to the fifth x over 5 minus sine to the seventh over 7 plus c. So again, another iteration of things that we've used before, meaning the u substitution, or in this case w substitution, but given the table in the back. And again, number 23 back there, it can be fairly convoluted. There are a lot of different options, like let's say m was odd this time, so this was cosine to the third and sine to the third, something like that. Then you have a different stipulation. In that case, this would not hold true. You'd have to do something else for that. And it gives you all those different options back there to take a look at. All right, let's try a different one. Let's do something with a fraction. So I'm going to assign you guys some of those homeworks today. Also, be sure that, I know I send the text sort of early, like today I sent the text at like 8:30, something like that. But when I film these, I'd like to be able to go through some problems with you guys instead of just posting the answers on there. And sometimes it's not always beneficial to just see the solution, even with all the work handed out. Sometimes it's nice to be able to, for me to verbalize what I'm doing. And I can't do that on just a piece of paper. So if you could respond back with, yeah, I want to see number 2, number 3, whatever have you, I'd be more than happy to. All right, let's try this one. Let's do the integral of 3x plus 7 divided by x squared plus 6x plus 8. A couple of things you should always try to notice whenever you have a quadratic in there is that most likely it's factorable. Oh, sorry, I forgot to do that. Although it is fairly rare that it's factorable, sometimes when the book gives you something or when you give you a problem specifically with one, most likely it will be factorable. So in that case, we can take our denominator here, factor that into, I believe this one turns into x plus 2 and x plus 4. Yeah, I think so. That's going to be really important because now when we go back to our table, go and take a look at, let's see, I'm thinking this one needs table 5, and I think number 27 on table 5. That formula reads as such, that if we have cx plus d divided by x minus a times x minus b, and we want the integral of that dx. It reads 1 AC plus B, plus D, times the natural log of the absolute value of x minus A, minus BC plus D, times the natural log of x minus B, the absolute value of that, plus C. Okay, so it seems like a lot, and it is. And if you can't read my chicken scratch here, you can certainly, again, look in the very back of your book. I strongly suggest having that open while you're doing these. But the key to this one is just noticing what numbers equal what variables, and luckily we have a lot of practice with that. So the first thing I would do here is I would start to label out what is A, what is B, what is C, what is D, and from there it's just filling stuff in. So in this case, A, since it should be x minus A and it's currently x plus 2, that means that this had to be minus 2, therefore A is negative 2. Same thing with B, that should have been x minus 4, therefore B is 4, C must be 3, and D is then 7. C being the coefficient and D being the constant. And then just start filling stuff in. 1 over A minus B, times A times C plus D. I know, I'm in the way, I apologize. Times the natural log of the absolute value of x minus A. And I'm not simplifying it yet. If that becomes confusing, just fast forward. And then B times C plus D times natural log of x minus B plus C. Just taking all of our variables, plug them in. And now we will go ahead and simplify these as much as possible. That's 1/2 times -6, 1, natural log of x plus 2, -12, -5, +5, times the natural log of x plus 4, plus C. All right, I'm going to go ahead and stop this recording and then start a new one.